So here we have a 150 kilogram dog with a jetpack traveling at 8 meters per second. He's going to use 60 newtons for 12 seconds in order to go faster, and we're going to find out how fast he actually gets up to. Now we're going to do this question two different ways. One using basic F equals ma, VAT type stuff, and the other way we're going to do it is we're going to look at it in terms of momentums, because we were talking before in the previous video that they're the same ideas, just a different aspect and viewpoint, and sometimes it's easier for some people to see it one way rather than the other way, but we'll sort of piece things together. So if we did a basic, F equals ma type method, we've got the force, we've got the mass, so I can find out the acceleration. So acceleration is force divided by mass, and I can do the 60, it's not going to be a very big acceleration, I can do the 60 divided by the 150, and I can find out that he's only accelerating at 0.40 meters per second squared. Now, typically what you would do is then you could find the delta V using acceleration as time, because you have the acceleration. We can times that by the 12 seconds, and we can find out that the change in V is going to be about 4.8 meters per second. Well, now it's pretty straightforward. The dog started at 8 meters per second, so we got the 8 meters per second right there. It changed by 4.8, he's going faster, so all we'd have to do is add the two together. We have starting with the 8, we'll add the 4.8 to it, and we get a final speed of 12.8 meters per second. And then you could find the average speed to find the distance and all that kind of stuff too if you want to. It doesn't make any difference, but that is how you could find the new speed using basic F equals ma VAT type stuff. Now let's look at the exact same question except in terms of momentum. Now, of course, the dog starts with momentum, and we can find out his first momentum. We've got the mass, we've got the V. So if we do that, we can take the 150 and we'll times that by 8, and we can find out it's got about 1200 kilogram meters per second of momentum. I also have the force and the time. So with the force and the time, I can find his impulse. So I do force times time, I can find out how much his momentum changed by. So I do the 60 times 12, I get an impulse of 720 kilogram meters per second. So then to find out his new momentum, I just have to add the two together. Started with the 1200, add the 720, and his final momentum would be 1920 kilogram meters per second. Now that I have his final momentum, all I have to do to find his final speed is just use the same expression we used up here, except divide by the mass in order to find the new speed. So I'll take that 1920 and I'll divide that by the 150, and we will get a speed of 12.8 meters per second, which is the exact same answer we got the other way. So there really isn't too much of a difference between how many steps there are and that type of stuff. It's just a different way to look at the question. So like we're talking about before, you can do similar types of questions that you did before with F equals ma and VAT and that type of stuff, just using momentum ideas. Some people prefer one method over the other, but really it's not that much different between the two, just a different aspect and viewpoint in terms of how you want to actually take on the question.